Welcome to qnawire.
Okay, so the ratio of initial speed to the final speed of the sound should be equal to C1 over C2, which is square root KRT1 over square root KRT2. As you can tell, KR here can be cancelled out. So this will give us C1 over C2 is equal to square root T1 over T2. And we know T1 is the initial temperature and T2 is the final temperature in this case. So since the air expands isentropically, so therefore the relationship between the temperature and the pressure can be expressed something like this. Okay, and P1 here is the initial pressure, P2 here is the final pressure, K here is the specific heat ratio for the air. So therefore, we have square root T1 over T2 is eventually equal to P1 over P2 to the power of K minus 1 over 2K. So therefore, we have C1 over C2 is equal to P1 over P2 to the power of K minus 1 over 2K. So we know the initial pressure is 170 psia, and the final pressure is 60 psia. The specific heat ratio for the air is 1.4. So now let's plug in back to the equation to determine the ratio of the initial speed of the sound to the final speed of the sound, which is equal to 170 psia over 60 psia to the power of 1.4 minus 1 over 2 times 1.4. And this will give us the ratio of initial speed of the sound to the final speed of the sound is about 1.160. And this is the answer for this question.